Okay, continuing on our sensitivity journey, what happens if we change the objective value of a non-basic variable? So we'll look at the version of Geppetto's problems where we've got soldiers, trains, and building blocks so that we have an original variable of building blocks that is actually non-basic. Question is, how much can the profit for building blocks change without changing the optimal solution? And so right now, there's not enough profit from building blocks for us to start making building blocks. But if it were to increase enough, then we would sort of change our basis and bring building blocks into that basis. So let's recall our dual constraint corresponding to building blocks, because they're our non-basic variable, is our dual constraint is 0y1 plus 2y2 plus 0y3 has to be greater than or equal to C3. And since I'm going to be changing this, I'll put C3 bar. Okay. Originally, I said that C3 had a value of 1, and we found that this dual constraint is satisfied when C3 equals 1, which means that we're dual feasible, which means we're primal optimal. Okay. And we know the values of, I guess this is Y, F, Y, C, and Y, D. Okay, not numbered, but lettered. I'll try to stay consistent with that. And we know the values of our dual variables are 1, 1, and 0. Those haven't changed. Just kind of as a note, maybe kind of Y transpose equals CB transpose B inverse. And so as long as we don't change the basic variables costs or the basic variable columns, which form the B matrix, our Ys don't change. Okay, and so that's actually a beautiful thing. Changes to the non-basic variables don't change Y. Okay, so looking at this and filling in the values of 1, 1, and 0, this becomes 0 times 1 plus 2 times 1 plus 0 times 0. And that gives us a value of 2 is greater than or equal to C3. Okay, so as long as C3 is less than 2, then we're not going to make any building blocks. Okay, and so X3 will remain non-basic. And if it's non-basic, it has a value of 0. If C3 is less than or equal to 2. So if I'm not making at least $2 in profit, I'm not going to make any of those building blocks. However, if C3 is bigger than 2, if I'm able to sell them enough of a markup that I can get $2 in profit from each one, then we will begin making building blocks, which means that X3 will be a basic variable. It'll enter the basis. Okay, and if that's the case, if we increase C3 large enough that it's now bigger than 2, then we will do the same thing that we did when we added the X4, the stacking towers, and we would kind of continue the primal simplex method. And if that's the case, X3 becomes basic, which means then we would continue primal simplex. We're still going to be changing C3 is not going to affect feasibility. It will affect optimality, and so we will continue on with the primal simplex, and that we'll still have a primal feasible solution, and we'll keep moving towards a primal optimal solution. Okay, so changes to the objective value are going to show up there. What happens if we change values in the column? So that's sort of the coefficients of the constraints if it's a column corresponding to a non-basic variable. So what happens if we change the number of carpentry hours for building blocks? How much can we change those without changing the optimal solution? And so let's again look at that dual constraint. And we'll write it out as essentially A13 YF plus A23 bar YC. And we'll note that the carpentry hours for building blocks, that's this coefficient right there. Plus A33 YD. And that's got to be greater than or equal to C3. Okay. So in this constraint, A13 and A33 are both zeros and we're not messing with them. So we'll go ahead and say that's a 0 and that's a 0. And so what this ends up being is A23 bar, which is the one that we're changing, times YC, which is 1, has to be bigger than equal to C3. And if we go back to the original value of C3, that was going to be 1. Okay, assuming that we're only doing one change at a time. So here's kind of looking at it from what happens if we change the profit. Now we're kind of fixing the profit at $1 per building block and see what happens if we are able to just kind of cut corners on the maybe the manufacturing process, reduce the number of carpentry hours. So maybe we implement some sort of profit process improvement there, or maybe we'll just make them smaller so that they take less work to do. And so now we're playing with the number of carpentry hours for those building blocks. And that essentially says that as long as A23 bar is bigger than or equal to 1, then this will be primal, or no, dual feasible. Okay, and if it's dual feasible, then it's primal optimal. Okay, well, let's put that in words. So if the carpentry hours for blocks is bigger than or equal to 1, so if it takes more than 1 hour of carpentry labor for each of the building block sets, then X3 will remain non-basic. Okay. However, same sort of thing that we can think about here. If A23 bar is less than 1, then X3 will enter the basis. Okay, and again, that means that we will sort of have a new column there, and then we'll continue the primal simplex. Okay, in both cases here, we end up with the reduced cost if we were to make a change of increasing C3 to more than 2 or decreasing A23 to less than 1, we'll end up with a negative reduced cost for X3, and it will enter the basis, and then we'd continue on with our primal simplex method. Okay. How much can the finishing for building blocks change without changing the optimal solution? This is actually an interesting question because we're currently not spending any time finishing for the building blocks. And so that would be looking at A13. So let's write A13 bar times Y finishing plus A23 YC plus A33YD is greater than C3. Let's put in the values we know. And so A13 bar, YF is equal to 1. plus A23, its original value is 2, times YC is 1, plus A33 is 0, and YD is also 0, and that's got to be equal to the original value for C3 is 1. Okay, so 1 times A13 bar plus 2 is greater than or equal to 1. So 2, I'll subtract that over the other side. So this is kind of a weird one in that A13 has to be greater than or equal to -1. Okay, so in essence, our current basis will remain optimal as long as A13 is greater than or equal to -1. Now, in this scenario, finishing hours can't go negative. You can't have anti-work, no matter how unproductive your coworkers might be. There's no such thing as anti-work. And so, yeah, we can't have negative hours of finishing. And so in this case, no amount of finishing for blocks can make the X3 variable basic. Okay, we're not doing any increasing the amount of finishing only makes the building blocks a less attractive product to make. And so we don't really need to change finishing. It's not really a lever that we really want to mess with. Okay, and no amount of messing it with it is going to improve this. And so, yeah, those are changes to a non-basic variable. Okay, we can change the objective coefficient, its contribution to profit. We can change the values in that variable's column. So essentially the amount of resources consumed in making that product. So whether that's carpentry hours as our resource or finishing hours as our resource, we can look at, well, what if we kind of changed our process of making this product to reduce the inputs or reduce the kind of resources used? Those would all be changes to the non-basic variable column. Okay, so that concludes for non-basic variables. The kind of maybe the moral of the story is check the dual constraint. The dual constraint will tell you anything, everything. If the dual constraint is satisfied, you remain at the same basis. If the dual constraint is violated, then you're going to continue the primal simplex method until you get to an optimal solution, which will then be dual feasible. That's it for this video.